in previous lecture, we show the reaction of HCl, that means reaction of primary, secondary and tertiary alcohol with Lucas reagent, and after that we also show the Lucas test, and this Lucas test is also known as a identification test of primary, secondary as well as tertiary alcohol. Okay. Then we know that the reactivity of hydrogen halide, that is HI, is more reactive than HBr than HCl. HCl is least reactive. Therefore, this HCl is reacted with alcohol by using anhydrous ZnCl2. Anhydrous ZnCl2 act as a Lewis acid, and also it act as a catalyst. Okay. Then now we shows the reaction with HBr. Then this is the point: reaction of alcohol with HBr. Reaction of alcohol with HBr. In this reaction, the reactivity of HBr goes on increases, or it is a higher than HCl and it is a lower than HBr. That means according to reactivity of HBr, this HBr it is situated in between HCl and HBr, because the reactivity of HBr it is a smaller, or it is a slower than HI, and it is a greater than HCl. Okay, but the reactivity goes on increases, the stability goes on decreases. Reactivity goes on increases, then stability goes on decreases. Therefore, this HCl is not directly used in this reaction, because the stability, reactivity increases. It is reactivity of HBr, it is a greater than HCl. Therefore, slightly reactivity goes on increases. That means the reactivity increases, stability decreases. Due to this least stable than HCl, the least stability of HBr than HCl, then this HBr we can't be used directly with alcohol. Then this HBr it is prepared is in situ. This HBr is prepared in situ. Therefore, this preparation, situ means it is a separately prepared. Separately prepared. It is prepared separately, or separately preparation is here. Then how they prepare the HBr? The HBr is prepared by the mixing of NaBr plus concentrated HCl, or instead of this HCl we can also use the concentrated H2SO4. Here we write the concentrated H2SO4, then it forms the HBr plus NaHSO4, sodium hydrogen sulfate. Okay, then this HBr, this is a preparation method of HBr. By this HBr it is prepared in situ, that means it is prepared separately, and this separately prepared HBr now we consider, or now we use in the reaction of alcohol. Okay, this is the separation, this is a preparation method of HBr. Due to the stability, least stability of HBr, it is prepared in situ. Okay, now we consider the reactions. Then firstly we consider the primary alcohol. When primary alcohol is reacted with HBr, but the reactivity of the stability of HBr it is a least, that means the reactivity of HBr goes on increases. Therefore, it is prepared in separately by the using of NaBr plus concentrated H2SO4. NaBr plus concentrated H2SO4. Then it gives corresponding alkyl bromide. Similarly, in this reaction, this primary alcohol, the mechanism of this primary alcohol is also carried out as according to SN2 reaction mechanism. In this case, first preparation method is that, first step of mechanism is that there is a protonation of alcohol. After this protonation, there is a formation of electron deficient carbon atom, and this nucleophile, that is the Br minus, attacks on this carbon atom. At that same time, the water molecule, it should be eliminated from this water molecule, the hydroxyl group coming from the alcohol and hydrogen from the HBr. Then it forms their corresponding alkyl bromide plus H2 is here, the corresponding alkyl bromide. Okay. Then this is a primary alcohol. If the primary alcohol is reacted with HBr by using NABr and concentrated H2SO4, this NABr and concentrated H2SO4, it is a preparation method of HBr. Okay. Then it forms their corresponding primary alkyl bromide. It forms a corresponding primary alkyl bromide. Okay. Then we also take the secondary alcohol. This is the secondary alcohol. If the secondary alcohol is reacted with HBr, and this is a preparation method of HBr, it is prepared by the mixing of NABr and concentrated H2SO4, NABr and concentrated H2SO4, then it forms a corresponding secondary alkyl bromide. Their corresponding secondary alkyl bromide plus water molecule should be eliminated. Okay. Then also we can take the tertiary alcohol. When tertiary alcohol is reacted with HBr by using NABr and concentrated H2SO4, then it forms the corresponding alkyl bromide. Then it forms a corresponding tertiary alkyl bromide. Okay guys. Now here we consider primary alcohol, secondary alcohol, and this one is a tertiary alcohol. Okay, this alcohol is reacted with HBr. The stability of HBr, it is the least, therefore it is prepared in separately, or it is prepared in situ. In this reaction, the water molecule, it should be eliminated. That means the bond, it should be break down between carbon, oxygen, hydrogen and bromine. Here similarly carbon and oxygen bond, it should be break down. That means the cleavage between carbon and oxygen, and it also HBr bond, it is also break down. Similarly this breaking bond breaking is also found. Then this bond breaking is not with HBr. Therefore, this bond breaking is happening by using this solution is refluxed. This secondary alcohol is refluxed with HBr. This tertiary alcohol is refluxed with HBr. Reflux means it having a strongest heating. Okay. Due to this reflux or due to this strongest heating, the bond, it should be easily break down between carbon and oxygen and hydrogen and bromine atom. Therefore, this reaction is carried out at hot condition, and if primary alcohol or it is a secondary alcohol or it is a tertiary alcohol is reacted with HBr, then this reaction is undergoes reflux, or we consider reflux means a strongest heating. The reflux is the most important word which is used in this reaction. Okay. Now we goes towards the mechanism of this reaction. This is a primary alcohol. This primary alcohol mechanism of this primary alcohol is according to SN2 reaction. That means in this case there is no rearrangement reaction is possible, because in this SN2 reaction there is no formation of carbocation here. But this is a secondary and tertiary alcohol. If reacted with HBr, the reaction mechanism of this reaction is according to SN1 reaction. According to SN1, there is a formation of carbocation is formed, and after formation of carbocation, we will study the two examples before in the Lucas test or Lucas reagent. That is, a secondary carbocation get converted into tertiary carbocation by two methods. It may be hydride shift, 1,2 hydride shift, or it may be a 1,2 methyl shift. Okay, by this shifting the rearrangement reaction is possible, and after rearrangement the secondary carbocation get converted into tertiary carbocation. That means the reactivity of carbocation it goes on increases, and after increasing the reactivity, that means after formation of tertiary carbocation from secondary carbocation by rearrangement, that means 1,2-methyl or 1,2-hydride shift, then formation of tertiary carbocation. After that, the nucleophile directly attacks on tertiary carbocation, and there is a formation of stable product. Because in this SN1 reaction mechanism, the carbocation is more, the stable carbocation, it forms a stable product. Okay. Then this is a general reactions of primary, secondary, and tertiary alcohol. When primary alcohol is reflux with HBr, then it forms a primary alkyl bromide. When secondary alcohol is reflux with HBr, then it forms the secondary alkyl bromide, and tertiary alcohol is reflux with HBr, then it forms the tertiary alkyl bromide. Okay. Now we take the examples of this reaction. Okay. First example is that C2H5OH, second one is a C3S7OH, then third one is a cyclohexanol, fourth one is a CH3, CCH3, which is here, there is a CHOH, and this is a CH3, and last one is a CH3, CH3, then CHOH is here, and CH3. It is reacted with or reflux with HBr. It also reflux with HBr. It also reflux with HBr, and this one is a HBr. Okay. In this reaction, the product is formed their respective alkyl bromide. In this reaction, there is a reflux, but HBr it is prepared in separately. NABr plus concentrated H2SO4. This is similar reaction condition is used in all these reactions. Okay, then water molecule it should be eliminated, and there is a formation of ethyl bromide plus H2 is eliminated. Okay, from this molecule the water molecule is also eliminated, then it forms their respective alkyl bromide plus water molecule should be eliminated. This is a cyclic alcohol, but this is a not aromatic alcohol. Okay, therefore the water molecule is also eliminated, hydroxyl group from cyclohexanol and H from the HBr, and there is a formation of cyclohexyl bromide plus water molecule should be eliminated. But in these two examples, fourth and fifth numbers examples, it having a water molecule it should be eliminated. After elimination there is a formation of secondary carbocation, and after formation of secondary carbocation there is a hydride shift is possible. Due to this hydride shift, due to this rearrangement reaction, the respective product is that CH3, CH3, the Br is attached here, then CH get converted into CH3, and CH3 is also formed. Okay. Then last reaction is also similar with fourth reaction. In this fourth reaction, there is a 1,2 hydride shift is here, but in case of fifth reaction, there is a 1,2 methyl shifting is here. Firstly, this oxygen is attract the H plus ion from the HBr. There is a formation of protonated alcohol. After protonation, water molecule should be eliminated, and after elimination, there is a formation of secondary carbocation is formed here, or positive charge is coming on this carbon atom. Then this carbocation is converted into tertiary carbocation by the by the methyl shift by the 1,2 methyl shift. That means this shifting it is also considered or also included in the rearrangement reaction. Due to this rearrangement reaction, the secondary carbocation get converted into tertiary carbocation, and there is a product is that CH3. This one is the Br is attached here. Then CH. Then CH3 is shifted to this secondary carbocation, and there is the formation of CH3. This is a examples of alcohol and HBr. The HBr it is prepared separately in situ by using a NABr plus concentrated H2SO4, and in this reaction the bond it should be breakdown or bond breaking is possible because of why? Because the reaction condition is at hot. That means that this reaction is reflux with HBr. Okay, this is some examples of HBr. Okay, then after that we also study the reaction of HI. The reaction of HI. Okay. The reaction of HI. Okay, now we'll study the reaction of alcohol with HI. Okay, we see in previous lecture the reactivity of hydrogen halide, that is that HI is more reactive than HBr than HCl. HI is more reactive than HBr than HCl. Now we studied the reaction of HI. Then firstly we consider the primary alcohol. When primary alcohol is reacted with HI, when primary alcohol is reacted with HI, then it forms their respective alcohols. Their respective alkyl iodide. Then water molecule it should be eliminated. Okay, but in this reaction, this oxygen atom which carries the lone pair, therefore it attracts the H plus ion from the HI. In between H and I, the bond it is the weakest bond because the size of iodine is goes on increases. Therefore, bond strength it goes on decreases. Therefore, in between hydrogen and iodine, there is a weakest bond it should be formed. Due to weaker bond strength, this bond is easily break down. Therefore, this oxygen by using a one lone pair, it attacks on the H plus ion, and after withdrawing there is a formation of protonated alcohol. Okay, after formation of protonation, this I minus is attached on this carbon atom. At that same time the water molecule it should be eliminated. That means this is a primary alcohol, and if primary alcohol is reacted with hydrogen halide, the reaction mechanism it should be continued according to SN2 reaction mechanism. Okay, but in this case the bond making process and bond breaking processes occur simultaneously. Therefore, for the bond breaking between H and I, we recommend the heating for this reaction. For heating, after heating, the bond it should be break down easily. Therefore, this reaction, the product of alkyl iodide is formed very easily. Okay, that means when primary alcohol is heated with hydrogen iodide, then it forms a alkyl iodide. Okay. Now consider the secondary alcohol. This is a secondary alcohol. This secondary alcohol is also heated with HI. Okay, there is a water molecule, it should be eliminated. The hydroxyl group from the alcohol and a hydrogen comes from the HI. This water molecule is also eliminated from alcohol and hydrogen iodide. Then after elimination of water molecule, there is a formation of a secondary alkyl iodide plus water molecule it should be eliminated. This is a primary alkyl iodide and this one is a secondary alkyl iodide. Okay. After that, we consider the tertiary alcohol. When tertiary alcohol is heated with, this is a tertiary alcohol. This tertiary alcohol is heated with HI. The water molecule is also removed from the alcohol and HI. Then heating is must be possible. Then it forms their corresponding tertiary alkyl iodide. Then it forms the tertiary alkyl iodide. Okay, that means in this reaction, when a second primary as well as a secondary alcohol is reacted with HI, but in this case the reactivity of tertiary alcohol is also greater and the reactivity of HI is also greater. Therefore, these two are the more reactive. Okay, that means the tertiary alcohol and HI, both of these is a more reactive. Due to this more reactivity, the yield of product it is a much lower or much smaller than the normal yield of the product. Okay, that means in case of tertiary alcohol, when tertiary alcohol is heated with HI, the reactivity of tertiary alcohol and reactivity of HI both are shows in highest reactivity. Due to this highest reactivity, their respective, their corresponding product, it is a much less stable. Due to generally this reaction is not seen in this topic or in this reaction. Okay, that means in our syllabus there is a primary alcohol as well as secondary alcohol. Only two alcohols are present here. Okay, but the mechanism of secondary alcohol is followed by according to SN1 reaction. Is followed by according to SN1 reaction. That means this oxygen, it withdraws the H plus ion towards itself, and there is a formation of, firstly there is a formation of a protonated alcohol. There is a formation of protonated alcohol. This is the first step. In first step, protonation of alcohol it should be formed. In second step, there is a formation of carbocation is here. In first step, there is a formation of protonated alcohol. After protonation, there is a water molecule is here, and this water molecule it act as a base leaving group. Therefore, it eliminated or it is leaved this alkyl group, and there is a formation of secondary carbocation. There is a formation of secondary carbocation. Okay, in second step means there is a formation of secondary carbocation. Okay, after formation of secondary carbocation, in third step, the nucleophile, that is remaining H minus, is easily attached on the this secondary carbocation, and there is a formation of this product. Then that means the reaction is carried out according to three steps. In first step, there is a protonation reaction is also occurred. In second step, there is a carbocation is also formed, and in third step, attack of nucleophile on the carbocation, and there is a formation of secondary alkyl iodide. Okay, this is a general reactions of alcohol which is reacted with a HI. Now we consider these some examples of alcohol which is reacted or heated with HI. Okay, now we consider here CH3CH, CH3, then this is a OH. Okay, then propan 2-ol is here. This propan 2-ol is reacted with heated with HI. Then one water molecule it should be eliminated. This is a secondary alcohol. Then secondary alcohol when heated with HI, the reaction mechanism is carried out on the basis of SN1 reaction. Then it forms their respective alkyl iodide, that is a water molecule it should be eliminated. That means 2-iodopropene is here. 2-iodopropene is here. Okay. Now we consider the CH3, CH3, H is here, then CH2, CH3 is here, then OH group is attached here. This one is also secondary alcohol. When secondary alcohol is heated with HI, okay, then this water molecule it should be eliminated. That means the mechanism of this reaction is also carried out in 3 steps. In first step, there is a protonation of alcohol is formed. That means the CH3, CCH3, this hydrogen, then this CH, this OH. By using this lone pair, oxygen attracts the H plus ion towards itself. That means the OH get converted into OH2, and after formation of one extra bond between oxygen and hydrogen atom, then oxygen shows the positive charge. Then there is the CH3 is as it is here. Then it forms a protonated alcohol. That means this reaction, this mechanism is shown in this step. That means the H plus is here. This H plus is coming from the HI. Therefore, by using one lone pair, this oxygen attacks on the H plus ion, and there is a formation of protonated alcohol. Then CH, CH3, CH, OH2 is here. After formation of one new bond between oxygen and hydrogen atom, then positive charge is shown on the positive oxygen atom. Okay. Then this one is a first step. In this step, protonation of alcohol is formed. In second step, there is a protonation of alcohol, but in this protonated alcohol, there is a water molecule is formed. This is a water molecule is here, and this water molecule is act as a base leaving group. Therefore, this water molecule is goes or it is a eliminated easily. Okay. After elimination, the carbon shows the positive charge. That means there is a formation of carbocation. There is a formation of carbocation. Okay. Then after formation of the carbocation, now we comes towards the third step of the mechanism. Then this is a this hydrogen is created in this form, then CH plus is here, then CH3, there is a formation of secondary carbocation. After formation of secondary carbocation, there is a hydride shift is here. That means there is a rearrangement reaction. By rearrangement reaction or 1,2 hydride shift, that is rearrangement reaction, the secondary carbocation get converted into tertiary carbocation. Then is a CH3, that is a positive charge here. Then CH get converted into CH2, then CH3. Here they form the tertiary carbocation. That means the secondary carbocation get converted into tertiary carbocation by the 1,2 hydride shift, or the secondary arrangement step is here 1,2 methyl shift. 1,2 methyl shift. Okay. Then after that, this tertiary carbocation is formed. After formation of tertiary carbocation, the remaining part, that means this nucleophile, that means this I minus is attacks on the tertiary carbocation, and there is a formation of this product, that is a CH3, CCH3, I, then CH2 and CH3 here. Okay. Then this is a reaction, and their mechanism is the formation of their corresponding alkyl iodide. The similar reaction, that means in this reaction there is a rearrangement reaction, and one of the molecules also shows the rearrangement reaction. This rearrangement reaction is that there is a molecule name is 3,3 dimethyl butan 2-ol. 3,3 dimethyl butan 2-ol. That means here one hydrogen is replaced by CH3. Then this molecule also shows the rearrangement reaction, but in this case the 1,2 hydride shift is not possible. But in this reaction there is a 1,2 methyl shift is here. Now we write down the mechanism of this reaction, we considering the 1,2 hydride shift, that is a rearrangement reaction. Okay, then this is a reaction of hydrogen iodide with alcohol. Okay guys, now in this lecture we shows the reaction of HBr as well as reaction of HI with alcohol. Okay guys, thank you.